So we ended the last mini lecture introducing the idea of magnitudes. I'm going to do a couple of examples. Okay. So the ratio of brightness. So the L stands for luminosity here. So the ratio of brightness, the brightness of one star compared to the brightness of another star. Okay. So you want to find the ratio of brightnesses. Now, you don't know how bright each star really is, but you can still find the ratio of brightness, the difference between the two, by doing this. So let's say two stars. So we have our table of data here, okay? And so I can pick out a star and pick out another star. So let's say Alpha Carini, okay? So Alpha Carini right here, okay? And let's say 44 Andromeda. So this is the brightest and dimmest star on this list, okay? So the brightest and dimmest visible star. Now, there are other dimmer stars. For example, this star, but that's too dim to be seen with the naked eye. This star is slightly too dim to be seen with the naked eye. This star is too dim to be seen with the naked eye. But among the stars you can see with the naked eye, now remember, how do you know? It has to be brighter than magnitude 6 to be visible. So the ones that you see, the dimmest one you can see is 44 Andromeda, and the brightest one on that list is Alpha Carini. So I want to know what's the ratio of brightnesses of those two stars, L1 compared to L2. And so that's going to be 2.512 raised the difference in magnitudes. Now in math, we often use a little delta M to mean difference in magnitudes. Okay, now students always want to know, I don't know what L1 and L2 are. Well, you don't need to know what L1 and L2 are. In order to find L1 and L2, you just do 2.512 raised the difference in magnitudes. Well, what's the difference in magnitudes? Well, for Alpha Carini, then the magnitude was negative 0.067. Okay, for 44 Andromeda, then that's 5.70. So the difference in magnitudes is going to be subtracting these two. And so you subtract 5.70 minus a negative 0.067, okay? And a negative means you add, so so that's going to give you a difference of 5.767. So the exponent is 5.767. So how do you raise something to the 5.767 power? Well, there's a button for it in a calculator. So you do 2.512 raised to the 5.767. And so the answer is 203 times brighter. Okay. Now, how do I know I did 5.70 minus that negative number? Why did I not do this minus that? Well, if I did this minus that, the answer would have been negative. And if the answer is negative, it's wrong. It has to be a positive number. So, for example, suppose you have like a star, star A, and the star A has a magnitude of minus 0.5, and you have another star, star B, and that has a magnitude of minus 0.75. Okay, and so I want to know what's the difference in brightness between those two stars. So the ratio of brightness is L1 to L2 or B1, B2, either way. Okay, it's going to be 2.512 raised the difference in magnitudes. So I need to find the difference in those two numbers. Okay, so how do I do that? Well, I subtract. Okay, so I can do negative 0.5 minus a negative 0.75, and the answer is 0.25. Now, I could have done negative 0.75 minus a negative 0.5, but the answer will be minus 0.25. That's wrong. You have to have a positive exponent there. So this is going to be 2.512 raised to the 0.25 power. Okay, so how do you raise something to the 0.25 power? There's a button on the calculator, 2.512, and you raise that to the 0.25 power. And so that turns out to be 1.26 times brighter. Okay, and so that's a couple of examples here of using magnitudes and finding brightness with magnitudes. Now, you actually have a whole lab in which you're going to be doing this sort of thing, so you need to kind of get familiar and comfortable with that. And so you're going to be using this concept, and this is what you're going to need to know. Always the delta M, the difference in magnitudes, is whichever way you subtract gives you a positive number. If it's not a positive number, it is wrong. If it's wrong, you're not going to get the right answer. Okay. The ratio of brightnesses. You do not need to know either one of those. The answer you can get without knowing those. You do not divide the magnitudes to do that. What you do is you do 2.512 raised to the difference in magnitudes. This is the power of this. You don't actually have to know these numbers right here to find the ratio of them, because the magnitude measure allows you to skip a whole bunch of mathematics. And so that's why we do this. So this will be a good introduction here. This and a couple other topics involving distances are going to be one of the labs you're going to be doing. Okay. All right, so magnitudes are a way of measuring brightnesses of stars. You measure magnitudes, you measure brightnesses. Now, the next topic we're going to undertake, however, is measuring distance. And that's a whole lot more complicated to measure the distance of a star.